All right. I think thanks everybody for coming today. I know a few people couldn't make it. Had mentioned. I know Marco's last minute couldn't make it. I think a couple other folks told me they had last minute things they had to go do. And I see we have somebody new. How do you say that? Madid?
Udit, yes. Here,
Okay.
let me
You want to
start my
introduce
video.
yourself? Yeah. Welcome to the club. Yeah.
Yeah, hi. Thank you. Yeah, my name is Mudit Tyagi. I'm an architect in the office of the CTO at F5.
F5. Great.
And prior to that, I think 4 different startups. So
Oh,
the
nice.
first one was in the space of bringing layer 3 routing decision into a chip with a company called Rapid City that was bought by Bay, which went to Nortel. Then we did a company called Incra Networks, which was the first one that did virtual network functions, etc. And that went piecemeal to Cisco and Nortel. And then we did a company called Nevis Networks, and which was a security company out of Bay Area, which went bankrupt. And then Nambala, which was a data science company out of Georgia Tech that
Nice.
basically
Okay.
mapped all of the domains in the internet and used the mainframe to do machine learning modeling in order to come up with a risk score for every single domain in the internet, etc. So that's the short, brief experience in this
Well, I really appreciate you use the words mainframe because that's what I grew up in, Madid. So I appreciate
space.
that.
And I appreciate the words Georgia Tech because that's where I went.
Did you go to Tech?
Excellent.
Okay. Good school. Yeah.
I actually know a couple people that went through Bay Networks. They ended up at Fidelis Cybersecurity, where I work with them.
Excellent.
Yeah, that was a good group. They
Yeah.
Bay Networks definitely had some issues though.
Yes, indeed. I was very young at the time, so I didn't see the issues. I was just trying to learn stuff.
Yeah.
But now when I look back, you know. Uh,
Well, again,
and so
what?
this is my first. I've just started to jump into this, and I've started to look at the activities of the group, and I'm going to start. I would love some advice on where should I begin in terms of understanding how far the thought process has come. I'm looking at my starter documents that I should study, and
Okay.
then I'll be able to, begin to contribute.
Perfect. So, Madid, if you want to set up a call with Russ Warren, I'm the project manager. I can kind of walk you through where we are, what we've been. The good news is the architecture stuff, all the meetings have been recorded. They're out there on GitHub or YouTube, and the notes are also out there. So at least you can get some history. But I can, if you want to set up a call, I'll take you through where we're at, what we're doing, because it's multifaceted.
Perfect. I will do that.
And as I tell all this group, it's also very exciting. So we're all exhausted. Yeah, have a good time.
Excellent. Good to
Okay.
meet you all.
Welcome. Yes.
Thank you.
Welcome, welcome. Okay, I do have still a few comments from the architecture document that I'm still working on. Some of you have sent me in. I haven't caught up with all of them yet. I got distracted a little this week, unfortunately, so I apologize for that. So I'll get back to those. So I still owe you guys, some of you guys, some comments, and I'm hunting down some material from some of you as well. So you'll know when I'm hunting you down because I'll be after you. But we'll continue to work that. So that is in the background. It's not going to be in the agenda today because I have nothing really new to update. But we were very fortunate that our friend Bill has decided to help us out here. And he's going to take us through a diagram that I think I sent out on the email for this call and talk a little bit about the domain he's been working in and share with us some of the things that he's been working on over there. So Bill, if you'd like, I'd turn it right over to you.
All right, that sounds good. Thanks very much. Let me go ahead and share. I've got an amazing set of slides that I'll start sharing. Hopefully you can see what I've got going on here.
Yes.
Good. All right. So I'll start with a few acronyms. SACM, Security Automation and Continuous Monitoring. It's a working group in the IETF. There's an architecture draft. A couple of us here on the call, myself and Adam Montville, are the two authors on that draft. And the initial initial draft, the initial authoring of this focuses really on posture attribute collection, evaluation, or what I may say posture assessment when I talk about that. So we consider that kind of the combination of collection, evaluation of those posture attributes. A lot of what the SCAP group has focused on, is a little bit of this as well. When the SCAP 2.0 efforts began, there was some focus on architecture, and over time, the two kind of the SACM architecture and the SCAP architecture started to blend a little bit. Sort of the same groups kind of started to be on the same, on both calls and both working groups. So they kind of sort of are morphing into a similar idea. So the two are similar in what they're trying to accomplish. With kind of the main difference with SACM, I believe, is that SACM's trying to be a little bit more content or integration service agnostic, and be able to adapt to different payloads of information or different messaging kind of frameworks and things like that. We've done a little bit of sort of hackathon or proof of concept work in the IATF. They're good enough to kind of host hackathons before each of their kind of one. They have meetings 3 times a year, and before that, kind of have a weekend of being able to do some implementations and test interoperability of their different drafts and give away free beer and things like that. So it's a good time to stay up late and write a lot of code. We did a little bit of work in there with some different messaging frameworks back in the day, like XMPP, but we've always had been kind of focused on using simplified SCAP content. So oval objects, oval definitions, things like that to invoke collection. There's a link down here to the draft, and we're still working on that and continuing to update that as well. The draft is kind of focused on a couple of major pieces, and that's capabilities and operations. Capabilities, what can a particular component do within the ecosystem? Can it collect posture attributes? Can it perform log aggregation, persist information to a repository, maybe ingest telemetry information from outside sources, or receive information from observational collection, things like that. The architecture allows for the components to advertise or perform like a service discovery type operation or thing like that, so that components can basically, when they're onboarding and registering with the ecosystem, they basically send their component or their capability listing to the manager that tracks these capabilities, and then, for example, using OpenDXL, what that broker and that manager can do then is associate those capabilities with the different topic namings, and then given particular topic names, then that's where the OCA Ontology can take over, which can help describe the operation type, whether or not it's a directed action or a broadcast event or anything like that, along with the specification of the message payload and the data model that goes along with that message payload. The operations, some of the common ones that we've defined in the draft are listed here, but both capabilities and operations can be defined really from any of the security domains represented in the various OCA diagrams, or really from any domain wishing to exchange information. So it's really just a model of producers and consumers, and the message and the integration fabric to allow for that data exchange. And I'll show the diagram that was passed around in the email. And without further ado, I will go ahead and do that once I minimize that. The first thing I'm going to do, this is the diagram that was sort of passed along in the email, but what I'll do first is I'm going to show a quick kind of view. These are the different sort of diagrams that we have contained in our draft right now. And like I mentioned before, if I put this guy in here and slide over, we basically just have producers and consumers, right? You know, exchanging messages using an integration service like OpenDXL. And when we kind of take a look at that from a collection perspective, we've got a couple of components in here that have advertised their capabilities. For example, we've got the manager that's going to orchestrate collection via an
Yeah, audio is gone.
Yeah, Bill's. I didn't know if it was me or Bill.
Yeah, Bill's audio
I'm
seems to be
back.
gone.
I didn't know if it was me either.
We'll rescue him.
Well, it's a good diagram to reflect upon as we wait.
That's right. Yeah, this gives you a chance to absorb it.
Yeah.
Russ, are you able to Slack Bill?
I'm gonna chat him right now. We lost you on audio.
Can you guys hear me now?
Yes,
Yeah.
you're back.
Weird. I seem to have lost power there for a second. That was awesome. I'm glad
You
that'll be
lost your
recorded.
power. Okay, wow, that's been pretty severe.
I'm glad that'll be recorded. Okay. All right. So, yes, disruption indeed. Okay. So, what was the last thing you heard?
You just put that diagram up.
Okay, great. I will go back to trying to share this guy. That correct? Can you guys see that? Can you see
Yes.
that diagram now?
Yes, we
See
can.
it, and that's the
Great,
same one
good
we were
deal.
stopped
Okay.
on.
Perfect.
Perfect. Okay, so back to where I was. This is sort of a bit of the diagram of components that we do have defined and would advertise their capabilities. And this sort of collection orchestration would happen and perform that collection through the various posture collection services. We have kind of two different ones modeled here, a sort of on the left here, an agentless collection service that can kind of reach out and touch the endpoints and gather those posture attributes, or an agent-based one sitting on the endpoint there as well. Let's see, if I then go to the big diagram, this is kind of rotating that diagram a bit, and I apologize for the zoomed in nature. I just wanted to make sure that everybody could kind of see what's going on. So the orange components here kind of dotting the outside represent those different components we saw in the previous diagram. So we've got the manager, we've got an orchestrator here, we've got a collector down here on the bottom left. The computing resources sort of represent the different endpoints collecting from, and a repository interface that would go ahead and persist right to the database, which is represented here by the blue. The integration service, so the OpenDXL broker would be represented here vertically in the middle, and the different sort of hot pink blocks in there represent different topics that will be used to exchange information. Now, what this represents mostly is sort of the orchestrator's view of things. So the orchestrator, and again, this is sort of precluded by the fact that the manager is on board and listens to a predefined topic here called Action Manager Component Registration. And that's a topic used for directed communication when a component onboards and wants to register with the ecosystem. So the orchestrator would come online and request its component registration over this topic. The manager then being listening on that particular topic we'll go ahead and generate a unique identifier for that orchestrator and persist that to its own sort of repository, its roster, so to speak, and would respond to that component registration with that particular unique identifier.
Man, Bill, he's got to pay his power bills, man. I don't know what's going on.
We could see his cursor moving.
Yeah, he's still
at least he
there.
hasn't
You
lost
just
all his
can't hear him.
power. That's right. He's still there. You're right. His curse, still alive.
And we have to tell him,
Yeah, I'll tell him again. On audio. I just sent it to him.
the cursor has stopped moving.
Well, that's not good.
So these, maybe I can ask a question. These, the signal generation agent, I forgot what Bill called it. There was a agentless approach and agent-based approach. In the agent-based approach, there are a few options. Agents running in user space, agents running in kernel space, or not agents, but kernel modules. Are those things that some group is reflecting upon? What is the best approach?
I mean, from an architecture standpoint and, the communications layer we're looking at here, I don't know that we distinguish between those two things at all, right? Each one could talk in whatever way it wants to. I mean, I understand the distinction you're talking about in terms of effectiveness and what have, but I feel like that's kind of an implementation question that
Sure.
may not necessarily be the domain of this group. I don't know.
Sure.
I don't want to speak for everybody though.
I'm new, so I'm just trying to understand. Yeah, that makes sense. Your answer makes sense.
Hopefully that's Bill.
Well, I don't think Bill ever dropped. Like, he's shown up as a participant the entire time.
True. Well, we lost his cursor movement and we lost his voice.
Yes.
So we got, you're
Try
right,
quick.
we got parts of Bill.
Can you try taking control, Russell? Or
Oh, hold on, here he comes.
Oh, okay.
Here he comes. Now he's back. I don't think the WebEx knows he's gone until he comes back. As you can see, it's resyncing.
Mhm. Yeah,
Here
I
he
see
comes.
the disruption in the force message and invoke Yoda.
Yoda's here.
Yoda's here.
There he is.
So I don't see him back yet. Come on.
Well, we can infer that he's working from a desktop instead of a laptop. So if he
Right.
doesn't have UPS.
Well, that isn't necessarily true. Just because the machine he's on has power doesn't mean the router it's connected to does.
That's true.
Come on back.
The question is, what does the dog think?
Oh, the dog?
Yeah.
Oh, he's honestly just he's done at this point. This is the end of his day. He's
Yeah,
tuckered
poor
out.
Bruce.
It's already Thursday. No more. He was working on GitHub stuff this morning and it's totally just beating the crap out of him.
Oh.
So while we're contemplating, how would an agentless, excuse me, collection engine work? I mean, would it be using, command line interface or something to query the endpoint?
Generally,
There are all
David, that's
sorts of
true. Yeah, generally your
There are
proxy.
all sorts of different ways.
Yeah.
It could be something like Tenables or Nessus, where it's looking for individual vulnerabilities and things externally, trying to probe certain points, seeing what comes back. It's entirely possible they could use built-in instrumentation, things like WMI, the Windows Management Infrastructure, to be able to query, installed software and then run that against an existing base. I mean, classically, that's the agent would be built into the operating system, but you'd kind of be subverting it a little bit for your own purposes.
Yeah.
It's kind of similar to what OS Query does.
Yeah, that's certainly one way, right? I mean, the other way I've seen agents being built is it's they're remote, and as you're talking about, David, they use remote APIs to get in there and pull the data back from the device. So that's another style.
Yeah, and that's really what I mean by WMI. It's just an example of
That's right.
a Windows-specific API.
You're a Windows guy. Yeah, that's right.
I mean, you've got some tools that will just like, on a Unix-based system, they'll SSH in and start doing whatever and use that as their comms channel.
Exactly. Yep. Exactly. So those would be two examples of agentless systems. I'm sure there are others.
Yeah, but I mean, anything that treats the system under observation as a black box and can just bounce commands off of it through already defined channels, is what I would consider agentless. And if, I'm trying to see, I don't know, let's say, Heartbleed, a little bit of an old example. I could start pinging, trying to send hello packets to the SSH, or sorry, the TLS daemon on the other side and seeing how it responds and analyzing those. That would technically be agentless too. I'm trying to see if it's vulnerable by trying to break it.
Right. Maybe he's had a worse power outage than previous.
That might have been the point where the UPS battery finally
It ran out.
that.
Where is Bill located?
I'm not sure.
Right now, probably somewhere very dark.
And warm. We'll give him a few more minutes.
Yeah, so when he was describing the SACM architecture and saying trying to be transport independent and content independent, that's the goal of OpenC2 as well. So when he showed a collect using Oval versus collect using OpenC2, that didn't seem quite parallel to me. OpenC2 is more analogous to the SACM architecture itself. So
Good
we'll
point.
have to,
Yeah, we'll have to ask him about that. Yeah, and then when I've looked at the SACM architecture, the things I have a lot of questions on, how do we interact with it? It sounded like you had a registry. Is there a central place that I can look up who the managers and the, what do you call them, the producers and the consumers are? Can I, as an example of as you know, we're working on our malware use case, right? We have an example where we have an email scanner and we have an endpoint scanner. To me, those would want to report into this system about a posture, right? So how they do that, I'm not familiar with. And then on the other end of it, I'm not familiar with is the manager sitting there? Does it have logs? Can a SIM talk to it and listen for it? Can a SOAR command to it? Those are questions I've had for the system. I haven't looked at the documents yet to see how the system talks to other systems.
And honestly, that's something that I've had a little bit of trouble with trying to piece together a lot of the protocols we've been talking about.
Yeah, yeah.
We tend to talk about particular slices of protocols and, you know, say, well, you know, it can write on anything or anything can write on it or what have you. But coming up with concrete examples tends to get real tough. Like in
Does
terms
it?
of, okay, well, I don't know, what I've seen is it's a little tough for me to be like, okay, well, OpenTXL can do all this good stuff. Cool. Like OpenC2 can ride on this. Great. You know, what is an example of all of these layers of the stack being put together into a concrete implementation? And I don't know. I feel like sometimes that gets a little lost. Like
Yeah, no, I agree with you. As a matter of fact, one of the things I'm chasing on the architecture is a layered diagram. I've been after some of the guys for that same thing. Is I'm even just trying to understand OpenC2 and the ontology and how that fits together. I think they're layered, but I'm not sure how. So you're right. And then the OpenDXL to me is the communication layer underneath it. Sure, I get that. I think. But you're right. I think you do need a nice layered diagram, like 7 layers of the ROSI architecture, right? Of being able to kind of lay out this one's on this layer, or they're on the same layer, and this has this subset of it, and the other one has the other, whatever. But I would like to know that better. Yeah, I agree.
Well, I mean, not just the individual layers, but honestly, you know, and the OSA 7 layer is a perfect example of that because you need like an example where you can break it down into these layers. You can say like, okay, this is a vulnerability assessment system talking to a SIM, and this is how that happens at each layer, and this is how those things would work out.
Yeah. Yeah, that would be valuable to have, Andrew. I agree. It's something that would be clearer on how things fit together. And I know we don't have that yet because I've been trying to get some data on that.
Yeah, we've been pretty tardy in the OpenC2 working group in coming up with an architecture document. You know, we started in on the protocol, but we realized that we need, you know, the framework that the protocol fits in, and it would describe, you know, the content layer, the message layer, and the transport layer, and hopefully that would make it easier for people to see how things are going on and actually have a use case for controlling something to do something and show how all of those work together.
Yeah, that would be valuable data. That would be.
I may have gone at what I was doing with the threat intel stuff from the wrong direction. Now that I'm realizing it, because I think I started possibly more with the OpenC2 actions than the architecture itself. So I definitely have some stuff to run past you, David, when Bill or after Bill does his thing today.
Yep.
Yeah, I'm not sure how long we should wait for Bill.
He's just happily talking away and just figures we're all mesmerized.
Well, right
in
now,
the dark,
he's
in front of a blank screen.
Yeah, the black screen because he's not on
With
WebEx
no
anymore.
power.
He's not on my list. Yeah, he's not here anymore because I can't send him messages. He definitely is. He's gone. He's definitely gone. It's ironic too when he left, Mitch and Adam left at the same time. They all hang out together. Yeah.
There's been some issues today with global routing. I don't know if anybody else has noticed or had panic phone calls as a result.
Really? Yeah. No, I haven't noticed today.
Yeah, there's been some weird stuff going on, especially some weird routing loops. I was noticing traffic going through Western Europe that should have been staying on this side of the pond. It's entirely possible that something has split things a bit, and maybe they're all co-located. I don't know.
Yeah, you don't know anymore. Okay.
Those dang Chinese.
What are they doing in Western Europe?
Oh, just testing out more
I
more
guess.
malware.
Yeah, I guess so.
Probably they decided to buy a Huawei here instead.
So we'll give Bill a couple more minutes, and then we'll either go to another topic or we'll end early, one or the other, and we can pick Bill up again the next call. You guys have anything else you wanted to cover while we're waiting for Bill to get back?
I definitely have something I want to cover.
Okay.
I'd like to throw out the stuff that I've been working on the threat intel actions,
Okay.
and see what people think of that. Right now, I mean, if you want me to start in on now, I can, and we can jump back to Bill when he gets there.
Why don't we
However
do
you
that?
want to
Because
do it.
I'm not sure that
Okay.
he's coming back based on the power outage. If it seems like it's more severe this time.
Well, I'm going to drop a link in the chat.
Okay. I see it.
And this is the my fork of the OpenDXL ontology page that we have.
Okay.
If you're really, really super familiar with the version that we have right now, you'll notice a couple differences.
I see some threat stuff in here. Yep. Yeah.
Yes. Well, it's not just the threat stuff. There's actually threat
SIM in here?
finding details had previously been submitted, but
Yeah, I submitted those. Yeah, we submitted those.
Yep.
Yes. Yep.
and those had not been reflected in the page because of the build issue. So
Okay.
I spent way more time last night than I intended fixing the build issue so that at least my
Oh, bless
fork
your heart.
updates
Bless your heart.
dynamically. And that's what I was trying to get in touch with Christian about,
Okay.
so that we could get it fixed on his version and I could submit a pull request for the threat intel stuff and it would all build. Like right now, I can submit a pull request and it'll get accepted, but it'll never reflect in the page until the build gets fixed.
Right.
Right. So I've been thinking about the threat intel platform in the architecture and what role it plays. And really, I came to the conclusion that it's probably a very, very passive role. It is not an active participant in the in that it doesn't really do a lot of stuff on its own. It's not like a SOAR platform. And in a SOAR platform or a SIM is definitely something I would consider an active device where things are going to happen on a schedule, on a trigger, what have you. The threat intel platform is probably going to mostly respond to queries or people giving it information. And I really just created two different categories of actions for it. Now, I have to admit, I have not been involved in the OpenC2 stuff, and I'm realizing that there's a very specific naming convention that goes on there for the requests that I have probably completely made a hash of. So again, think of these more like capabilities than specific names, and that's really why I want to get some comments on this.
Okay.
But I was really thinking the primary way of querying would be great if we could do that by a sticks pattern, and leverage the sticks standard, specifically that section 9, since it does have a very thorough section on developing patterns. But the vast majority of devices, I don't know if we're ready to say it's sticks only yet. So I just created some generic ones in terms of, hey, I want to search for a thing that maybe isn't necessarily represented in a generic sticks item, or you don't necessarily know what you're looking for. Fancy Bear is an actor, which could be described as an adversary in sticks, but maybe somebody doesn't necessarily know what it is at all and wants to get things like all the stuff related to that guy. Same thing with files. There are definitely ways of doing that through sticks, but I thought I'd create just a couple very simple endpoints in terms of I know exactly what I'm looking for and I want info on that. I expect those to be used by things like SIMs who have some type of information. They know the category they're looking for. Somebody sees an IP in a firewall log and wants to see, hey, what does the threat intel system know about it? Is it good? Is it bad? I do need to model the output formats for those guys. I, just kind of created some key value pair, kind of like lists of attributes as a response for the most part. I noticed that in the base OpenC2 stuff, there was a split on IPv4 versus IPv6 addresses. It seemed like those were separate types. So I extended an object to those so that we could just say, hey, look, it's an IP address. Going forward, I really think that anything we do should be supporting IPv4 or IPv6 pretty like, we shouldn't be splitting them at this point. It's past 2020. There's no reason to make specific endpoints for IPv4 or IPv6. I'd rather just have a common type, which you can overload as either one.
We actually started out that way, and then we got pushback from some of the Sticks people, in fact, saying, no, you don't want to try to auto detect on a string and see whether it looks like an IPv4 or an IPv6. You want to label them so you know which they are. So we started out uniform and then split them because of that feedback. But yeah, we can do it either way.
Well, so I'm not. I understand the concern there, and I could definitely, especially when you get into like IPv6 mapped IPv4, there are some weird cases there. I guess the OpenC2 stuff that I was looking at, and I think this was something that you had brought up last meeting when you were talking about defining different types and as kind of aggregations of others and extending types. There's and maybe this is a really bad example, and it's probably going to show my complete lack of understanding of this entire system. There's this OpenC2 schema that I'm dropping a link into the chat right now that was utilized as part of the OpenDXL ontology. And I guess there were separate definitions there for V6 and V4. All I did was just create an object that could reflect either one. And, if you're familiar with C socket programming at all, this is very similar to the address type structure where it could be either one depending on how you do it. All I wanted to do was say, hey, look, when you're using an address, if you use the address type, you're going to support both. And from the perspective of, trying to filter somebody down so that, this thing supports 4 only, or this thing supports 6 only. There's a way of defining whether the thing is 4 or 6. And if you support this particular type, that means that you're going to be able to handle either as long as it's structured correctly. I don't know if that makes sense. Sorry.
Certainly, it's a goal to be able to refer to them generically. I think the way you had in the ontology is a reasonable way to do it. You encapsulate them. You have an IP, and then beneath that you tag it as V4 or V6.
Yeah, that sounds right.
And actually, I just realized that the version that I did pasted in there is the wrong one. I'm sorry. It should be the version on the thread intel branch that has the update that has the IP address definition that as an object that can encapsulate it. So not a whole lot of stuff here. Like I said, I got way more tied up in the how of updating this stuff than the actual updates in a way. But hopefully I'm past that hiccup now. But in general, I think it's really, the thread intel platform, at least as I'm seeing it, and please, somebody else has other use cases that they're thinking of, I'd love to get them included. But the main one I'm seeing is there is a thing, and that thing is able to ask for information. You know, and that ask may be either a single piece of, I want context on this thing, or I want all the IP addresses you have because I want to know which things I should block.
Right.
I'm probably going to extend those queries out with some type of filters available. You know, making sure that but those will probably happen through sticks patterning anyway. Being able to say, these are the things I want to block, have some intent behind it that's tracked in the threat intel platform. But that's kind of the long and short of it. You can give it stick stuff to hold on to for later and digest, and you can ask for things from that library. But I really kind of see it like a book, a library. You know, you put things into it, you pull things back out, but he
Right.
doesn't do a lot on his own. That's where the sword comes in.
Yep. Yeah, I think you're right. I think those are the two principal actions. There's a lot I think that happens under the covers there, but yeah, those are the two actions I see that are important.
Yeah, I think the next step is probably trying to figure out how we generically represent some of those relationships, and hopefully, you know, Sticks does handle most of those, but trying to get those put in. I feel like that's a really big opportunity for Stick Shifter, since it is sitting there, you know, able to take in those queries and possibly represent some of that data itself, regardless of what format it's originally in.
And you reminded me, Andrew, I got to send you the Project Kestrel that was proposed at the PGB, which is threat hunting language on top of Sticks. I got to send you that.
Okay. Yeah.
Because I think that'll be relevant for what you're looking at, because it'll also show you some of the example queries that we're doing at that layer. And the intention there is to kind of bundle up what a threat hunter would ask a threat intelligence platform, and then pull those Sticks queries underneath and just drive the interface for the operations. So you know, click by click, hunt by hunt. You could do it as a pattern of things that you look for.
So that's
the
kind of first step that I've got on the threat intel stuff. I just kind of want to see thumbs up, thumbs down. Is this the kind of stuff we're looking for? Should I be digging deeper into this? Should I be representing this in a different way? What kind of thoughts we have?
Well, it's definitely, to me, it's the kind of stuff we are looking for. I do know I want to pull a diagram around it. Remember the old C4 diagrams, but I think the raw material you got here is exactly what I'm looking for in terms of how it interacts with everything else around it. All right, so we can capture that in the use case we're working on. So that's perfect. Thank you for that.
Yes. So I'm looking at the ontology, and it's got a set of topics that contain a lot of information. You've got action query host by IP, and then you've got the payload with the IP address in it. OpenC2 was designed as a graph interface rather than a REST interface. So everything would go to a single endpoint, and then the fact that it has an action that's query and then you want to do it by host would all be part of the payload. So I think we'll want to create a mapping between where you are in the graph, and this is a great set of examples to work from. So how much do you put in a path versus how much do you put in the payload itself? And I guess you can, if we're defining an ontology, we would want an automated mapping from this multi-endpoint, this path, or the path-based architecture to a payload-based architecture. And so yeah, this is a good set of data to try to play with to see how that might work.
Yeah, and I have to admit that my knowledge of OpenC2 itself was coming down to monkey see, monkey do with the existing ones there. So I was looking at, okay, what do we have? Action quarantine device by host name, action quarantine device by MAC address. Like, okay, well, then I'll add a lot of buys and we'll go from there. But yeah,
Yeah.
if there are better ways to represent that, if you can give me some examples, I can make sure those get updated appropriately.
Yeah, so I guess if we had non-OpenC2 derived actions that we wanted to perform, you know, something based on sticks, for example, then yeah, I could try mapping that back into OpenC2, because we don't have a very rich set of use cases. We were focusing mostly on, the framework for capturing use cases rather than richness of the use cases themselves.
Well, would it help if I wrote up the use cases that I was thinking of when I initially kind of went through these? I mean, would it help to take a step back there?
Yeah, to take some input that was not OpenC2 based, yes, that would be
Cool,
that'd
because
be
like I said, the ones I was thinking of again were like, all right, I'm a guy sitting in front of the SIM. I see a log entry come in from the firewall, that looks, weird, and I want to see based off of the IP address of the destination, whatever my threat threat intel platform says. So I click on it, whatever, and I can write those up pretty easily and definitely have those up.
yeah, that'd be a help.
Yeah, that would be good.
Yeah, perfect.
Yeah, we've kind of been joking. Yeah, we've been working on OpenC2 for 5 years now, and now we can tell a packet filter to block an IP address. There's not much use case work there. There's a lot of framework work going on, but use cases are what we're lacking.
Yeah.
Well, I can definitely write up use cases around Intel platforms and
Perfect.
Project Thor as well.
That'd be great.
So I honestly, my biggest thing is just trying to figure out what end to start at sometimes.
No, absolutely. There's multiple prongs to all these things. So you did the right thing. Dive into a piece of it, and then we can have a footing to work off of. So I do the same thing. It's like if I'm worried about all of them, I get nothing done. So I'll pick one and start there. So good strategy. I like it.
Well, I'd rather be doing something, even if it's possibly the wrong thing, than nothing.
No, this looks good. Good start. Okay, anybody else have anything you want to add? I think Andrew, you've done a great job pulling that together, and I'll talk to Mark also about the build and the issue there. He's supposed to be overlooking those projects as a TSC lead.
Yeah, well, just have him ping me, and we can talk on it. I'm definitely
Okay.
on the OCA Slack, and
Yeah.
I'm on
Perfect.
Slack pretty much 24/7 for other
Mark's
stuff.
pretty good on OCA Slack. Chris isn't at all, but Mark is. So Mark Mastrangelli, he's on our Slack, and he's better at using it. So that's good. All right. Anybody have anything else? Any other ideas of topics you would like me to see in our next meeting, which is 2 weeks from now? I mean, I'll poll anyway, but if you had any top of mind, I'd love to know.
Many things, but I think, Russell, I should meet with you first, and then.
Yeah. Why don't we do that? So I get you up to speed, tell you what we've done, where we got some piles working up, and then where we've got areas that we're still thinking about. So yeah, let's meet,
Yeah.
and then I'll work with you. Yeah.
Yeah, I got very interested in this work because I've been researching in the CTO's office a lot of in situ mechanisms for in situ packet processing, in order to discover patterns that are not necessary. So if you think about a layer 4 packet, sorry, if you think about an HTTP request, which is sitting inside TCP transport layer payload, which is sitting inside the IP payload. If you draw one big nice rectangle, you start seeing IP addresses, options, TCP, ports, source, destination options, etc. And actually, since it's on the wire, all of this is sitting in a MAC frame, and you see the source, the MAC layer, source, dest, etc. What what our research shows, what we can do, and I did a Black Hat discussion on this, is we can actually pick patterns that apply to potentially several IP addresses, or a singular IP address, but we then start to detect patterns. So it's single source IP address. We start to detect patterns up in the OSI layer. At TCP layer, we start to detect patterns that are anomalous. So that are generators of anomalous payloads that DOS a service. So now I want to block. I don't want to block based on the IP, because the IP could be a mega proxy. There may be lots of good people behind that IP. I want to block that IP plus the specific patterns that I see in the TCP layer, detectable at a packet filter layer, meaning you're still doing packet processing. You're not trying to put the stream together and make sense of it. These are still, if you were to do a Wireshark, and at Wireshark inspection level, without opening up the protocol details, you can find these patterns, which we can generate dynamically and tell a packet filter that can look deeper than IP addresses to, or if you think the simplest thing is a regular expression of sorts, to block against the pattern. Very useful in fighting DDoS, etc.
I need to talk to you about something. I I'm going to send you a patent that it actually describes something very, very similar. But I don't want to waste everybody else's time. But I definitely have some stuff to talk to you about.
Yeah, and the thing is, what I think about is, how do you communicate these patterns that go beyond IP addresses to other security devices that could mitigate based on these patterns? And I was thinking, using sticks, etc. But I haven't dug deeper into how do you communicate. It's threat intel, but it goes beyond what we traditionally use in threat intel feeds. We use URLs, we use IP addresses.
Right.
But we can go beyond that.
You need a serialization format, effectively.
So it's a very interesting. So this. I started to ask the question and I said, let's go to a standard that is already involved in communicating this information, rather than trying to invent something new.
It seems also like you might want to use something that can describe a DAG.
Yeah.
So there's probably some techniques for try-like expressions, or something that can compress down into a serialization of try-like expressions, where you have dependencies and relationships as you describe them. MAC to this header to that header, and patterns within those. And there's obviously a pattern describes a decision point, right, where there's conditionals, like where if this matches that, and so forth.
Yeah, exactly. Yeah.
Yep.
Especially just at the packet level.
Just off the top of my head, as you were describing that, I was like, sounds like a graph.
Yeah. And the other interest that I have is actually in obtaining the signal. Some of it you get from from, networking devices, firewalls, and
Mhm.
load balancers, etc. But as we were looking at Bill's presentation, signal coming directly from the endpoints. So my interest is, one of the research interests is the endpoint on the server side. So not necessarily the endpoint that employees or human users use, but endpoints on the server side. So and API endpoints, the workloads that are actually running the logic that is producing responses to all these requests. I'm starting to look at grabbing signal from those endpoints, server-side endpoints, analyzing that signal and generating threat intel out of that signal. So anyway, I don't want to take your time, but Russell, much to catch up on and see how to plug in. And
Yep.
of course, I want to help with the ongoing streams.
Great. Sounds great.
One thing that might help, especially, I don't know, I'm really new at this, and it seems like we're getting more people involved looking at the Slack stuff, more people in the introductions, which is great. It might help if we just had a queue of, whenever something comes up that we're kind of like, yeah, it would be great to have X, but we don't have time for it right now. Just to set up a list somewhere of these are outstanding items that somebody could take a look at if they've got some time, just as kind of ways for people to get started.
Yeah, I actually have that out on
keeping
our wiki. If you've looked out there, I do
Okay.
have it out on the
I
wiki.
don't
Yeah,
know
you'll
that
see.
I have.
Take a look on the. Let me go find it.
Is
Which
this the wiki through GitHub or?
Yeah, the wiki in
Something
GitHub
else.
under the documentation wiki.
Okay.
It should be, if you go out there, let me just make sure that I didn't dream about this. Here it is, call for participation. If you go in there, you can add whatever you want in there. It's just things I know we need help with.
Which project is that under on
Documentation?
documentation? Okay. I've been looking through some other ones. All right. So
That is the place also that you will find all of
Awesome.
the meeting minutes and meeting notices and Monday. I don't know if you've seen that, but that's also where the recordings are for all these things. So that's my master list of everything that I do is out there. But if you did you just find it, Andrew?
Yeah.
Yeah.
And I just dropped the link in the chat too.
Perfect. Okay. Yeah. So just feel free to put it out there because I love using wikis. They're so easy, and just throw stuff out there under call for participation because that's where I've been parking stuff.
Cool. Yeah, it looks like we've got the 2 work items there, but we could definitely flush those out of it.
Absolutely. Yeah. Absolutely. That was a starter set, and I think we could certainly flush it out as you said. But that was the intention, is just to make it easy to go ahead and hack it into the wiki, and then we just continue to add these things as interesting items that we want to work on. And then we get enough people working on them, we can put a work group on it, like we're doing for the IOB.
I will start updating that as we come up with stuff. Cool.
Perfect. Okay, we're at 5 o'clock. It's 5 o'clock somewhere. Actually, it's 5 o'clock on the East Coast. So thanks everybody for joining. Bill sent me an email. He did have a power outage and didn't recover from this one yet. So we will get him back on the agenda in 2 weeks and pick up where we left off. And I'm sure we all have a lot of questions for him. And my intent of working with Bill on this was to just do a better job understanding the SCAP SACM stuff and figuring out how to relate it to all the other projects we have, because I don't think I did a very good job in the architecture paper about it because I didn't understand it well enough to write it. So hopefully that'll be one of our objectives, just trying to figure out how that fits into everything else we've got and exactly how the architecture works. And I think we have some questions for Bill when he gets back on how that is. Okay, so that'll be a good topic for our next call. Thanks everybody for joining. Have a great day.
Bye-bye.
Okay, bye-bye.
Have a good one.